humanity's ultimate dream, to avoid being dependent on just one corner of the universe, to become a true multi-planetary species. And the first stop we have chosen for this great adventure is the red planet, Mars. But transforming Mars into a habitable home means turning it into an entirely new world. In its current state, Mars is completely lethal. Average temperatures hover around -63 degrees Celsius. Its atmosphere is incredibly thin, just 1% the density of Earth's. This low pressure means that an unprotected human's blood would instantly boil. So, how will we confront this immense challenge? The plan is divided into two main phases. The first is colonization. Over the next few decades, we will focus on survival by building essential underground shelters on Mars. The second is planetary engineering, or terraforming. This is the colossal, multi-millennial dream of changing the entire planet to resemble Earth, creating a thick atmosphere and a viable biosphere. Transformation begins not with the planet itself, but with the journey to reach it. And this is where SpaceX's colossal Starship comes in. In 2026, the first uncrewed starships are set to launch toward Mars, a bold step into the unknown. If successful, by the early 2030s, the first crewed missions will follow. 12 pioneers bound for the red planet. Their mission is simple, yet monumental: to build Mars Base Alpha, and to turn Mars from a distant waypoint into humanity's next great harbor. To stay on Mars means to be self-sufficient. Bringing fuel from Earth isn't practical or economical. For every return journey, the fuel must be made right here on the red planet. Using carbon dioxide from the thin atmosphere and ice buried beneath the surface, the colonists will create methane fuel through a precise chemical reaction. This process is called in situ resource utilization, or simply ISRU, a technology that holds the key to both survival and logistics on Mars. The second pillar of Martian logistics is communication. Companies like Blue Origin are building this digital backbone. Scheduled for launch in 2028, the Mars Telecommunications Orbiter, MTO, will provide high-speed data transmission between Earth and Mars, a vital bridge for commands, coordination, and science. With the ability to carry over 1,000 kilograms of payload, this powerful satellite will form the digital foundation of Martian colonization, ensuring that every message, signal, and discovery finds its way across the void between two worlds. Mars's thin atmosphere, unlike Earth's, lacks a protective magnetic shield, leaving it exposed to intense radiation from the sun. That's why the first generation of Martian architecture will, by necessity, be built underground, a refuge carved into the planet itself. The finest shelters are the natural ones, lava tubes. Formed beneath ancient flows of molten rock, these vast, hollow tunnels offer more than mere protection from radiation. They also present a perfectly balanced environment, shielding settlers from violent dust storms and the extreme temperature swings between day and night. Living underground will not be easy. While initial settlements will be confined, future designs will evolve with human psychology in mind. High ceilings, artificial flowing water features, vertical gardens to support the oxygen system, and sun lamps that mimic the outdoors. It is these small touches of life that will truly turn Mars from a mere shelter into a home. There is evidence that Mars was once warmer, with flowing water on its surface. So what happened? Mars's core stopped, its magnetic shield collapsed, and the solar wind slowly stripped away the atmosphere. Yet, scientists have an incredible counter-solution. Placing a gigantic artificial magnetic dipole shield in Mars's orbit between the Sun and the planet. This would act as a massive umbrella, protecting the planet from the solar wind and giving it the time needed for its own self-warming process to begin. Crucially, this shield needs to generate an active field of 1 to 2 Tesla, a level that is technically within our reach. Once the planet is protected, the goal is to initiate a global greenhouse effect. Mars has locked reserves of carbon dioxide and water ice in its polar regions and soil. One method to release these involves darkening the polar ice caps, allowing them to absorb more solar heat. While some speculative ideas include importing vast amounts of greenhouse gases from comets, this would require a logistically unimaginable amount of energy. Even if the atmosphere thickens, billions of tons of oxygen are needed to make it breathable. A little-known fact is that plants don't just photosynthesize, they also breathe oxygen like us to store energy. The lack of oxygen on Mars inhibits even plant life. We will entrust this colossal task to the original terraformers of Earth, microorganisms like cyanobacteria. However, this biological transformation would take tens of thousands of years to create a breathable atmosphere on the surface. While the dream of terraforming is potent, the scientific obstacles are equally immense. NASA has officially stated that the amount of carbon dioxide locked in Mars's polar caps and soil is insufficient to create an atmosphere thick and permanent enough to make the planet habitable. With current technology and resources, the complete terraforming of Mars remains an impossibility. If it is impossible, then why do we still talk about it? The answer lies in the value of the dream itself. The very pursuit of transforming Mars is a major driver of innovation. This vision is a powerful catalyst, pushing the next generation of scientists and engineers to solve the hardest problems they can imagine. Why Mars instead of other space habitats? Mars offers us a sense of place. Unlike enclosed habitats such as O'Neill cylinders, Mars has a genuine horizon, a distinct sky tone, and a solid surface you can walk upon. This physical connection and feeling of reality is the philosophical justification for the quest that sees Mars not just as an outpost, but as a potential future home. The near-future Mars will consist of small human communities supported by the logistics delivered by Starship and buried underground for protection from radiation. In the distant future, however, should the magnetic shield succeed in protecting Mars, a slow transformation lasting thousands of years could be foreseen. A landscape where the planet gradually begins to turn blue and a liquid water cycle forms, settling Mars and transforming it. This is not merely a technical mission, but an evolutionary leap for humanity. The red planet is no longer just a crimson dot in the sky. It is a new horizon that represents scientific progress and our collective courage. It is a challenge, a promise, and a destination.